So, last class I have solved one problem considering layering effect. So, layer 1 is 5 meter, layer 2 is 5 meter, layer 3 is 5 meter, and first layer is gamma c and phi, second layer is again gamma c and phi, third layer is also gamma c and phi. First layer c is equal to 0, second layer phi is equal to 0, and I have given this as home assignment. You can try it changing the properties. Now, go to the example 2. A retaining wall of 8 meter high with a smooth vertical back retains a clay backfill. It retains clay backfill. The properties have been given. C prime is equal to 15 kilonewton per meter cube, phi prime is equal to 15 degree, and gamma is equal to 18 kilonewton per meter cube. Calculate the total active thrust. What is the questions? Find total active thrust on the wall assuming tension crack may develop. So, this is the case. There is a wall of 8 meter high, then the backfill is given. This is your C prime is equal to 15 kilonewton per meter square. It will be kilonewton per meter square. Phi prime is equal to 15 degree. Gamma unit weight of the soil is 18 kilonewton per meter cube. Now, what should be a Ka? Ka is equal to 1 minus sin phi by 1 plus sin phi, which is equal to 0.588, and Pa is equal to, it is a cohesive soil, so it is Ka into Pa minus 2c root over of Ka. So, at Z is equal to 0, Pv is equal to 0, then Pa is equal to minus 2 into 15 and root over of 0.588, which is equal to minus 23 kilonewton per meter square. At Z is equal to 8 meter, Pv is equal to gamma into Z, 8 into 18 into 8, and Pa is equal to 0.588 into 18 into 8 minus 23, which is equal to 61.67 kilonewton per meter square. Again, Pa is equal to 0, that means at Z0, which is equal to 2c by gamma root over of Ka, which is equal to 2 into 15, gamma is equal to 18 root over of 0.588, which is equal to 2.17 meter. So, if I draw it, how it looks like, this is my wall. So, in this case, so here it will be at the bottom, here it will be 61.67 kilonewton per meter square. Then here it is minus, here it is plus, and this is your 8 meter height wall. Here it is minus 23 kilonewton per meter square, and this height is your Pa is equal to 0. This height is your 2.17 meter. This is how your earth pressure distribution diagram will come. Top will be negative because at z is equal to 0, means depth, if I am considering this is my z is equal to 0, PV, particularly vertical force PV is equal to gamma into z. So, z is equal to 0, vertical force PV is equal to 0. So, Pa will be minus 2c root over of Ka, which is equal to minus 23 kilonewton per meter square, and z is equal to 8 meter. PV is equal to 18 into 8 because gamma is 18 and this is your 8 meter, and Pa is your 61.67 kilonewton per meter square at the bottom. Then it will vary from negative to positive, and with this negative value we have to find it out at what point Pa is equal to 0. So, Pa is equal to 0, that means at Z0, this is my Z0, which is equal to 2c by gamma into root over of Ka, which is equal to 2.17 meter. Now, total active earth thrust, if I can calculate it, so it will be 8 minus 2.17, which is equal to 5.83 meter. This distance is your 5.83 meter, because this negative I have taken it out. Either you can do it, take out the negative, only consider positive part. For economical design, here negative, here it is taking positive, entire part has been taken, only this part also to be considered. So, here I have taken out only negative part. So, then Pa will be half, this is your 61.67 into 5.83, which is equal to 179.8 kilonewton per meter. This is my active thrust. This is my second example. So, two examples has been solved based on your Rankine's theory. Now, let me go to Coulomb's theory. So, what are the limitations of Rankine's theory? If I start with the limitations of the Rankine's theory, Rankine's limitations of Rankine's theory. So, limitation of Rankine theory is theory of plasticity approach. First one, it uses the theory of plasticity approach. Second one is it assumes in Rankine's theory, assumes the condition of plastic failure is fulfilled at every point of soil. Again, another one is smooth wall. smooth wall, what does it mean smooth wall? That means friction between the wall and the soil is 0, that means there is no friction. So, in Coulomb's theory what they have considered, they consider the sliding wedge, and second one also they have considered friction between the wall and soil. What are their assumptions? Assumptions in Coulomb's theory. First one, backfill is dry, cohesionless, homogeneous, isotropic. Backfill surface is planar, and can be inclined. Backfill wall or back of wall, instead of backfill let me write back of wall can be inclined. Failure surface is a plane surface. Failure surface is a plane surface which passes through the heel of the wall. The position and line of action, the position and line of action of earth pressure are known. The sliding wedge is considered to be a rigid body, and earth pressure is obtained by considering limit equilibrium of the sliding wedge as a whole. So, what are the assumptions of the Coulomb's theory? The backfill soil is dry, cohesionless, homogeneous and isotropic. Backfill surface is planar, and can be inclined. If this is my wall, if this is the backfill surface, it may be a planar or it may be inclined. Back of wall can be inclined. If this is my wall, it may be vertical or it may be inclined. failure surface is a plane surface which passes through the heel of the wall, then position and line of action of earth pressure are known. The sliding wedge considered to be a rigid body. If I am taking a sliding wedge, this entire sliding wedge considered to be a rigid body, and earth pressure is obtained by considering limit equilibrium of sliding wedge as a whole. Now, let us consider Coulomb's theory, active earth pressure. In active earth pressure, here it is beta, let us put it A, then here B, then here C, and this should be your theta, this is W, and this angle is lambda, this is reaction force, then this angle will be your phi, this is normal force, and this is 90 degree. Then there is a friction between the wall and the soil, and this makes an angle delta, this is your P, and there will be a xi. So, this is how the wedge, this wedge makes an angle lambda. This is my wall, AB is my wall. It makes an lambda with this vertical, then here, and beta is the backfill is inclined, then here this is a lambda, failure surface is lambda, it makes an angle theta with your vertical, it makes an angle theta with your vertical, then P is your pressure, that because of here friction angle between wall and the soil, that is your delta, and if I am considering this is a wedge, the weight of the wedge is W, and here is a reaction force. So, how it has to be solved? It has to be solved by means of force triangle. So, this is P, and this will be R, and this is W. So, this will be 90 degree minus theta minus delta, this your lambda minus phi. So, R is your reaction force, P is your force because of your delta, angle between means friction angle between your soil and the wall, and W is your self weight, because this force triangle has to complete. So, this angle is your lambda minus phi, this will be 90 degree minus theta minus delta. So, considering this, so PA will be half gamma h square sec theta cos phi minus theta divided by cos theta plus delta root over plus sin phi plus delta sin phi minus beta divided by cos beta minus theta. its root over. So, it can be expressed as, it can be also expressed as PA as half gamma A square into sin alpha plus phi divided by root over of sin alpha minus delta plus root over of sin phi plus delta sin phi minus beta divided by your sin alpha plus beta. Then this is your whole square. When alpha is equal to 90 minus theta, if you look at here where alpha is equal to 90 degree minus theta. So, how it looks like? If this is my wall, this is my ground surface, and there is a wall inclined with this vertical at an angle theta, and this is your height h. So, this makes beta. So, PA will be acted at an angle delta. Delta is what? Delta is friction angle between the soil and the wall, and this is your height h. So, I am giving a typical value of your Ka for C is equal to 0 soil, where theta is equal to beta is equal to 0. Theta beta is equal to 0, what does it mean? The wall is here, theta is equal to 0 means it is perfectly vertical, beta is equal to 0 means it is no more inclined, rather it is a planar. So, simple wall case, what is the typical value of Ka considering Coulomb's theory? This is delta, this is your phi, which is 25 degree, 30 degree, 35 degree and 40 degree, and here delta is 0 degree, 10 degree, 20 degree and 30 degree. In this case 0 degree it is your 0.41, 0.37, 0.34, 30 degree 0.33, 0.31, 0.28, 0.26, 35 degree it is 0.27, 0.25, 0.23, 0.21 and this is your 0.22 and this is your 0.20, 0.19 and 0.17. So, these are typical value of delta varying from 0 degree to 30 degree. Once I am considering it is 0 degree, what does it mean? 0 degree means there is no friction, wall is very smooth, and these values as per your Rankine's theory, because it is 0 degree. Then phi is varying from, I have taken 4 values 25 degree, 30 degree, 35 degree and 40 degree. Delta is varying from 0 degree to 30 degree, and this is the range of the value, typical value. If you consider beta, if you consider theta also, these values can be generated. This is your entire syllabus for your earth pressure theories. Let me summarize. We have started with your earth pressure theories and considering for retaining walls, because it has to retain the soils and retaining your soils. So, that is why whereas the case retaining wall, anchor seat piles, brace structures. Then there are two cases, one is your no deformations or no displacement, in that case it is earth pressure at rest. Then case 2 is your one is moving away from the field, that is called active state, moving towards the field, that is called your passive state, no deformation, no displacement, that is your earth pressure at rest. Then for earth pressure at rest, we determine K0, which depends upon your Poisson's ratio mu by 1 minus mu. Then different values of K0 for soils has been given. Then there are two theories, one is your Rankine's theory, other is your Coulomb's theory. So, Rankine's theory, these are the assumptions. So, how this active state comes, walls moves away from. Then we have explained for active state and passive state how the Mohr circle looks like. Then active earth pressure on retaining wall for cohesionless backfill. 4 conditions I have discussed: dry backfill with no surcharge, then submerged backfill, then effect of surcharge, then effect of stratified soil in the backfill, phi 1 gamma 1 and phi 2 gamma 2. Then next one is your phi 1, in case 1 stratified soil phi 1 is greater than phi 2, second case phi 1 is less than phi 2. Then there are 2 examples, I have solved one example. Then there is a case of effect of sloping ground, then there is a case of inclined back of the well. Then it has been extended for Rankine's theory for active condition for cohesive soils, and for cohesive soils Pa is your gamma z Ka minus 2c root over of Ka. Then effect of sloping ground, we have derived what is the value of Ka. Then I have solved 2 problems for layered cases, other case is your for cohesive soils. Then I have gone through your Coulomb's theory, what are the limitations of Rankine's theory, then Coulomb's theory, then what are the assumptions, how the free body has been drawn, this is a planar wedge, and the force equilibrium from there Pa has been calculated. Then a typical value of Ka as per the Coulomb's theory for C is equal to 0 soils and theta and beta is equal to 0. This is what is your earth pressure theory is over. So, next class I am going to start pile foundations. Thank you.